Hello, Year 10, Mrs. Connor here again. We're on to lesson 4 of this chapter. I'm about to finish the first part of this chapter, split it into 2 parts. So we're doing the Pythagoras part at the moment, and this is the last section of that before we move on to trig. So if you could please rule off where you got to last lesson, write the title and the date, underline them, and then have a go at the do now task on this first slide. Please pause the video as you do this. Thank you. Right, lovely. So we're recapping how to find the area of a triangle. You're probably wondering why. It's actually quite important when we look at Pythagoras with isosceles triangles, when we're looking at the problem-solving questions. Now, there are 2 options for the formula: half times base times height, or base times height times 2. And these are 2 things that we looked at much earlier on in the year, at the start of year 10, when we were looking at area of shapes, and triangles was something we recapped. So for this first one here, we should know that the base and the height of a triangle always meet at a right angle, and that's why this 5 is nothing actually to do with the area. So we know that what we're using is the 12 and the 7 because they meet at the right angle. So what you should have done is 12 times 7, which gets us 84, and 84 divided by 2 is 42 centimetres squared. Remember, the reason we divide by 2 is because if you just do 12 times 7, you get the area as if it's a quadrilateral, like a square or a rectangle, and we know that a triangle is half of a square or half of a rectangle. So for this one here, you're doing the height inside this time. I won't show it very well with my pen here, but we meet at a right angle with the 2.5. 6 lots of 2.5 is 15. We divide by 2 to get the area of the triangle, which is 7.5 centimetres squared, and then we do this one. Now just be mindful here, the eagle-eyed amongst you will have noticed that the units are different. So you've got 2 options. You could either have made that into 110 centimetres, or you could have made that into 0.8 metres, but you need to convert one and then either use just the centimetres or just the metres. So if you went with metres, you'll be doing 0.8 times 1.1 divided by 2 is 0.44 metres squared, or if you went with the centimetre conversion and you were using 110 centimetres and 80, you would have done 80 times 110 divided by 2 is 4,400 centimetres squared. If you've not got either of those 2 answers, it's because you've just multiplied those 2 numbers together. We can't because the units are different. Okay, lovely. Right, so our success criteria today is to be able to find the hypotenuse of a given isosceles triangle in order to calculate the area. Silver's to find the area of other polygons, incorporating your knowledge, and then we're going to look at solving some problems, some complex problems using Pythagoras. Okay, so first things first, here is an isosceles triangle. We know that with Pythagoras, that works with right angle triangles. Well, an isosceles triangle isn't a right angle triangle. There are no right angles here, here or here, okay? So, well, how on earth can we find a missing side then? Well, we can do it by doing this. It has one line of symmetry. So if you split an isosceles triangle in half, you get 2 congruent triangles. It means they're both the same. But this line of symmetry down the middle, has now split them into 2 right angle triangles, okay? There. So now we can do Pythagoras to find a length. So to find that one, or actually even this height here. And we're going to look at how we do it today. So first things first, we're not going to look in detail at just finding missing sides, because we can do that pretty well when we're finding the hypotenuse in this. We're going to be asked to find the area, so there's a little bit more to this question. Now at the moment we know we can't, but from the previous slide we know that if we split this triangle in 2 from top to bottom, we get 2 right angle triangles, okay? And we know that to find the area you have to know the height. So the height is this side here, okay? Now we should know that with Pythagoras, we know that this longer side here, that's the hypotenuse, okay? So we're looking for a shorter side. So that should tell us that we're doing c squared minus a squared equals b squared. That's the formula that we're using. So we've got it here. So we're doing 7.5 squared minus 3 squared, okay? And then if we find the square root of that, we get if we do that subtraction, we get 47.25, and the square root is this long number here. Now again, for those amongst you that like to do a shorthand root, you know you can just do this here. So 7.5 squared minus 3 squared, okay, and it gets us straight to here. Now you don't take that off your calculator, you leave it on, because what the question is asking us is to calculate the area. And we know to find the area we can use one of 2 formulas. So we know we can do base times height divided by 2, or we can do half times base times height. And the good thing with this second formula here, this one, it doesn't matter what order the values are in. So we've got the height, so you just need to substitute that in. We know what the base is. The base is 3 because the height and the base meet at a right angle. So there's our base. So all you need to do in your calculator is write answer the ANS button, times by 3, and then divide by 2, or press the ANS button, times by a half, times by the base, which is 3, and you should get 20.6 centimetres squared. Right, we're going to have a look at another example together, and I'll ask you to copy this one down afterwards. So you'll sketch this triangle. So again, we're trying to find the area of this triangle. So the first thing we have to do is find the height. So we know we're looking for a shorter side because that's our right angle. So that's our hypotenuse. Remember the previous lessons, Miss did this 1,000 times. So we're looking for a shorter side because the hypotenuse is the longest. So, well, we need to work out what's our c squared. Well, it's our 16, but what's our b squared? So what's the base here, what's the other shorter side? And it's actually 10, because in order to find that height, we're just looking at this triangle here. If the whole thing is 20, we know that this is half. And we know it's half because it's isosceles. So those two sides are the same. And if we split it in half, we've got 2 equal distances here. So we do 256 subtract 100, which is 156. And then we know to find, that's actually our height squared, our a squared. So we need to square root it. And we get 12.4899999 and so on. Okay, again, just go back to this point. We know again that if we want to do it as shorthand, we can just do the 16 squared subtract the 10 squared, and it gets us straight to there. But again, we're trying to find the area. So now that we've got our height, well, let's times our height by our base, because if we use this formula here, it's the same as this. So you can just keep that answer in your calculator, do multiply by the base, which is 10, okay? Oh, sorry, not by 10, by 20, because we're looking for the whole triangle, silly me. So let me just get rid of that. We're looking for the whole triangle, so we times by 20, but that would give us the area as if it's a rectangle. So we're going to divide by 2, and we get 124.9 centimetres squared. Please pause the video, copy this down. You don't need to put all my red scribblings in if you don't want to, but you might maybe want to put the hypotenuse here and maybe the formula, and just pause the video as you get this all down to refer back to. Right, lovely. So I'd like to have a go at these 3 questions here. Just be really, really careful, particularly with C, okay, because this time you're given the height. It's actually the base you're looking for, so think about how you do it. So for the first 2, calculate the areas of these isosceles triangles. Do that first. Then have a go at questions 2 and 3, which require you probably to sketch something first to help you. Okay, please pause the video as you do this. Right, lovely. So for the first one, you should have 32.2. Remember, you're looking for that height. So it's 9 squared subtract 4 squared, and square root will give you this. You times your height by your base of 8 and then divide by 2. So here you should have for your area 2.83 centimetres. And this one is a little bit different, remember I said. So we're trying to find, because again, remember for a triangle, we're going with base times height divided by 2. We've actually got the height here, it's 7. So we need to work out what the base is. We're trying to work out what the base is here. Okay. Now, we've got a right angle triangle here, so we can work out this side of the base, so we just have to double it to get the whole thing. So again, that's the hypotenuse, so we are looking for a shorter side, okay? So what you'll be doing is, you'll be doing 10 squared minus 7 squared, and you'll get this distance here, okay? So we get 100 squared, take away 7 squared, so you're doing 100 minus 49 equals 51, and then if we square root 51, you get 7.1 and then loads of other numbers, but that's half of the base, so we have to double our answer. So we do 7.1 times by 2, and then we get 14.2-ish. You do 14.2 times 7 and then divide by 2, which gives you roughly 50 centimetres squared. I think it's 49.89 or something. Okay, right, just check those for me. If you've not done question 2, have a go now. I'm going to give you some insight to help you. So calculate the area of an isosceles triangle with sides of 8, 8 and 6. So the first thing you might do is you might draw it. There we go, 8, 8 and 6. Now it's just one of these questions, and if you've got these sorted, you can do this now. Let's split it in half, and now we can find what the base is of this right angle here, this right angle triangle here, just this one side here, okay? So we're looking for a shorter side, we're looking for the height. So you can do 8 squared minus 3 squared. Remember, the reason it's 3 is because we're just using this part of the base, which is half of the full distance. You get 55, square root of 55 is 7.41, and then a load of numbers afterwards. So we can do 7.41 times 6, because we're looking for the whole area of the triangle. Then we divide by 2, and it's rounded to 22.2. If you didn't get that, please copy it down. If you didn't get that and now you're thinking, oh, I can have a go at this one, again, pause the video and have a go. Otherwise, we'll go through the answers. So calculate the area. Now this time it's an equilateral triangle, so you should know that means all sides are the same length. So they're all 6, okay? So again, let's split it in half. We're looking for the height because what we're wanting to find is the area. So we're doing a shorter side. We know it's a shorter side because there's our right angle. So we've got the hypotenuse here. Okay, so what you'll be doing is 6 squared minus 3 squared, and the reason it's 3 is because that's 3 centimetres, it's half the full distance. 36 minus 9 is 27, and the square root of 27 is 5.19, and so on. You can then, because you've got 5.19 for the height here, okay, you can do 5.19 and so on. Keep it in your calculator, times by 6 divided by 2, and is 15.6 centimetres squared, rounded to 1 decimal place. Right, I'd like to have a go at this question for me, so you can pause it, we'll just read together. So it's a bit of an investigation question, a bit of problem solving. An isosceles triangle has side lengths of 6 centimetres and 5 centimetres. I would like you to pause the video and just do A. Sketch the 2 isosceles triangles to fit this data. Okay, so it's this data here. Please pause the video and draw the 2 potential triangles. Right, good. So if you're taught it's isosceles, you know that 2 sides must be 6 or 2 sides must be 5. But if 2 sides are 6 centimetres, the other one's the 5. And then if 2 sides are 5 centimetres, the other one is 6. Okay. Now, which of the 2 triangles has the greater area? Please pause the video, calculate the area of both triangles, and then decide which one has the greater area. Right, good. So first one, c squared minus a squared is b squared because we're looking for the height down here. So remember it's 2.5 because you're looking for half the distance here. So 6 squared minus 2.5 squared, we get 29.75, and we square root it and we get 5.45, but we're looking for the area, so we now know the height is 5.45, so we times that by 5 and divide by 2, and round to 1 decimal place you get 13.6. Okay, let's look at this one. So again, we're looking for the height. So again, we know it's a shorter side question because that's our hypotenuse. It's 5 squared, take away 3 squared. We know it's 3 squared because it's half the distance here. Okay, so 25 take away 9 is 16, and the square root of 16 is 4. So now we can do 4 times 6. The height is 4, the base is 6. 4 times 6 is 24, divided by 2 is 12. So we now know, oh, go back miss, that this one has the greater area and this one has the smaller area. Brilliant. If you didn't get it, please get it down. Oh, there we go. Right, next one. Right, I want you to listen really carefully and follow this. We're going to look at how we can use the skills we just developed when working with hexagons. So we're going to calculate the area of a hexagon with sides of 8 centimetres. But before that, I want you to sketch a regular hexagon showing all of its lines of symmetry. Please pause the video as you do this. Right, good. So you should have a hexagon that looks like this, and there are 6 lines of symmetry. Now the misconception students have is they'll go 7, 8, 9, 10, 11, 12, but we know they are already attached to lines of symmetry. So that's symmetry line 1, line of symmetry 2, line of symmetry 3. Okay, so there are 6. Now, you should also know that a regular hexagon is actually made up, battery's going, of 6 equilateral triangles. And there's an example of 6 of those. So you should know that they are both 8 centimetres. So what we're trying to do is find the total area of this hexagon. Now if we know that that side, just focusing on this triangle, is 8, and that's 8, we can find the area of this one equilateral triangle within the hexagon. We just have to use Pythagoras, so we need to find the height, which is here. Okay, now we know we're trying to find the height, so it's a short side question. So we're doing 8 squared minus 4 squared. Remember, the reason it's 4 is because that's half the distance here, and the reason you put the lines of symmetry in is because it breaks it up nicely into the equilateral triangles and it shows the height line. Okay, so 8 squared minus 4 squared is 48, and the square root of 48 is 6.928, and so on. Okay, we can now use that, because that's our height, to find the area of one of these equilateral triangles by doing our value, our height, times 8 and divided by 2, which gets us 27.71. But what that does is, that tells us the area of one. There are 6 of those equilateral triangles. Okay, so we times 27.71 and so on by 6, and you get 166.3 centimetres squared. What I would like you to do is calculate the area of the hexagon as if it has sides of 10 centimetres, okay? So similar idea, follow this system of working out, draw another diagram if you need to, but this time the hexagon has sides of 10. Can you find the total area of it? Please pause the video as you do this. Right, good. So we should know we're doing 10 squared minus 5 squared, because if they're now, if we draw one up here actually, if we know that's 10 centimetres, and that's 10 centimetres, okay, there is our equilateral triangle. It's 10 squared take away 5 squared, because we've got half the distance here. This is the triangle that we're trying to find. Oh, there we go. That's the one we're trying to find. Come on, miss, like an old woman using it. There we go. So we get 100 take away 25, which is 75, and the square root of 75 is 8.66, and so on. Okay, we can then times that height, because that is our height, okay, here, which is here, times our base, which is 10, we've got that here, and divide by 2, and you get this answer. But again, there are 6 of those within a hexagon, so you get an answer of 259.8 centimetres. Right, brilliant. Have a go at this question, please. Pause the video as you attempt it. Right, good. So a piece of land is in the shape of an isosceles triangle with sides of 6.5 metres, 6.5 metres and 7.4 metres. Show that the area of the land is 19.8 metres squared. We've looked at questions like this before. You're not trying to work out what the area is without being told. You are told this is the area, show that it is. So do the calculations. So let's draw our land that's in the shape of an isosceles triangle first. You're told what the sides are, so I've drawn it here. Okay, prove that this area is 19.8 metres squared. Okay, so we find the height using Pythagoras, and then we calculate the area. So that's what we're trying to find. We're trying to find this here. Okay, so we know we're doing, so that's 3.7 because it's half of 7.4. We know we're trying to find a shorter side because that there is the hypotenuse. So c squared minus a squared equals b. We'll say that's b if that confuses anyone. So 6.5 squared minus 3.7 squared. Okay, and you get 28.56, and the square root of that is 5.344, and so on. Okay, so we've now got the height, and there's more to it. Leave it in your calculator, because that's our height, and we're going to times it by our base, which is 7.4, and then we divide our answer by 2, and we get 19.8 metres squared to one decimal place, and then you've proved it. Okay. Right, just to finish, have a go at these two questions, calculate just the length. So we're trying to find how long this is and how long that is. So we're no longer looking for the area, we're just looking to find missing side lengths in isosceles triangles. Please pause the video as you do this. Right, lovely, so this first one here, we're trying to find the full length of the base. So what we can find is this distance. Okay, because we've got a right angle triangle. It's a shorter side question because that's hypotenuse, so we're doing this. Okay, 13 squared, oh, it should be minus 12 squared. Silly miss. So 169 minus 144 is 25, and the square root of 25 is 5. So that means this distance here is 5 centimetres. We want the whole distance, therefore we do 2 lots of 5 centimetres, which is 10 centimetres. Right, we'll have a go at this one now. So again, look, we're looking for the hypotenuse. So we know it's a longer side question, and this is our triangle we're using to find it. So it's a squared plus b squared is c squared this time because it's a longer side. Now, we start with doing 24 squared, which is this side here, short side, plus 10 squared. Remember, the reason it's 10 is because that full distance is 20, and if we split it in half, we get this distance here of 10. So you get 576 plus 100, which is 676. The square root of that is 26. Okay, you don't need to do anything else to it because we're just finding that length there, and it is 26. Brilliant. Right, lovely. Really well done today. So we've done the success criteria. just double check, see if there's any Hegarty tasks for you to do. There might be to go alongside this. Brilliant work, Year 10. See you soon.